Now we are going to do a reflection system. This is where we want our nodes of the graph to continuously communicate back and forth until our desired criteria is not met, or if there is a condition, logical condition that is breaking. So we are going to continue with GPT-5 model. We are going to keep the simple state as a message, and in that base messages we are going just adding as the messages are coming from AI human, and we have defined two prompts, a generate prompt, a reflect prompt. The generate prompt, what we are doing is like we are generating an essay, and then we are doing a reflection from an LLM to see uh, if that submission has good style, include depths and all things, and it is going to provide the recommendation. So this is the objective. How can we build such system? What is the first things that we need to know? So one thing is clear, that the generation graph is straightforward. It is going to take state. It is also going to return the state, and we are going to invoke the model. We'll first pass the generated prompt plus the state message. Well, let's say whatever be the requirement, and then from there we can return the message as response. We need to wrap this around as rest. Now the reflect one. Yes, it is also going to take the same state. Now we need to invert the message to get LLM to think on its own output. So let's do the mapping. Is what AI message will invert to human message. Human message will invert to AI message. So that's how you will make it think its own output as the human message. So now let's do the translation. So the first message is the original user request. We hold it same for all node. So let's do the reflected prompt, then state message. The first one is the human one. So this is going to be the base. And after that, you'll have to go the class mapping and message. So for message in state messages, except the first one, because that one we want. And what we need from here, so let's first do the message dot class for class.map.message, and then we want the content of this message. Class message, class content for message in state message. Perfect. So what we are doing, we are just reflecting it on its own output based on what class it is. So AI message, AI will become human, human will become AI. So this is the switching that we are doing here. Let's collect the response. Model.invoke, translate it, and then we can return messages as human message, because it is doing the critic, and content we can pass the response dot content. Now this can go on and on and on, but we need a condition which is like should continue. State. So if the length, let's make a condition, state message is greater than 5, In that case, we are going to return the end node, else we are going to return reflect node. And these node we are going to define when we are building the graph. So as the last step, let's build the graph. Builder state graph takes the state, and builder dot add node generate, then reflect is going to be the reflect, and then we can start adding the edges. Start will go to generate, and from there add conditional edge. From generate we can go to should continue, and then builder dot add edge, and from reflect it is going to generate, and our end condition will be invoked by should generate. So builder dot compile. So we have to pass an input state. It is going to be a message. Human message. Content. Write an essay about AI. So this is going to be the things that we want our state graph to do. Graph dot stream input state, we can collect the message type is generate, out else it is reflect. So let's print the very last message. Let's run it. So I'm ready to write. Would you like? Please tell me about preference, purpose, and audience. So this is the first message that our AI asked to the AI itself. Let's see what will be the output. So it is doing the reflection, and depending upon the LLM, it might take more time. So for me, it is taking some time, but I hope that you get the idea. And I'm not going to extend this video more. It's already become quite long. Thanks for joining. In the next session, we are going to learn about the subgraph, how to invoke a smaller subgraph from parent graph, like parent-child relationship. And till then, thanks for joining.